to share with you an example on the design of the beam bearing plate. Okay, so let us solve this problem on design of the beam bearing plates. So this is sample problem number 10. So we have an A36 bearing plate. So A36 means FY is 248. It is designed for a grade 50 W14 by 90 beam. So yung FY naman ng beam natin is 50 KSI that will rest on top of a concrete wall. So FC prime of the concrete wall is 20.7 megapascal, 200 millimeters thick. Okay, the end beam reactions are given such as 120 kilonewton dead load and 230 kilonewton live load. So it was given in the problem that the concentrated load that we're going to consider in the design of the beam bearing plate is the beam reaction. Okay, so questions. Letter A, design the minimum length of bearing plate required to prevent web failures. That is web yielding and web crippling. Okay, so yun yung L sa B. Then second, design for the minimum width, which is B, of the beam bearing plate required to prevent bearing failure on the concrete wall. Then last, we're asked to design for the minimum thickness of the bearing plate, which is thickness, required to prevent excessive bending on the bearing plate. Okay. Now, so it was also given in the table or in the slide the properties of the given beam section, the W14 by 90. No? So kailangan naman natin lahat yan. Okay, so for the solution, okay, so these are the given. So these are the properties of the bearing plate. I think yung FY should be 248 megapascal. While the FY of the beam is different, 345 coming from the 50 KSI. Then for the concrete wall, its compressive strength was given, the thickness is 200, and the bearing plate carries this dead load and live load as a support reaction. Okay, so that's the properties of the beam section. Okay, for the solution, okay, so design. So we will start with the length, the minimum length of the bearing plate required, and that is to address web failure. But before that, we have to solve first for the R sub U, that is the factored ultimate load on the support reaction coming from the 120 dead load and 230 live load. So we just need to factor it out. So we got 512 kilonewtons. So again, for the first part, we will be designing for the length against web failures. So let's start with the first web failure, which is the web yielding. So these are the equations needed for web yielding. So it would be case 1 or case 2. Since the problem says that the bearing plate would be designed based on the support reaction, so that means it will fall under case 1. No? So sa case 1 tayo. Andito siya. Kasi the load is at the end or near the end support. So this would be the equation that we're going to use. Okay, so the Rn would be Fy, thickness of the web, Lb plus 2.5 of K. And again, the resistance factor for web yielding is 1.0. Okay, then as per LRFT, the design strength, Vrn, should be greater than or equal to R sub U. Okay. Then, okay. So, yung resistance factor natin is 1. Okay, so resistance factor is 1. And this is Fy. Fy. Sorry. Okay, now, anong Fy yung ginagamit natin dito by the way? Anong Fy yung ginagamit natin dito? Okay, so this should be Fy of the web of the I section. Bakit Fy ng web of the I section? Kasi, di ba this is web yielding? So, ibig sabihin, yung nag-yield is yung web. Kaya dapat yung Fy ng web ang ilalagay natin, which is 345. So, ito, Fy ng web ng wide flange beam. Tapos ito yung thickness of the web from the table. LB plus 2.5 of K. K is as property of the section again, greater than or equal to the factored load, which is 512. So from this equation, we could solve for the minimum length L sub B for web yielding. And we got 45.4. Say, let's round it up to say multiples of 5 millimeters. So we got 50 millimeters. Again, that would be the minimum length of bearing plate for web yielding. Okay, next is, how about considering web crippling? Okay, for web crippling, so these are the equations for web crippling. So we have three possible equations. Again, this is case 2. Dito siya sa case 2 kasi the load is near the end of the support. Kaya lang under case 2, we have two equations pa rin. No? So what I did is I assume LB over D less than 0.2. So with that, I'll be using the first equation under case 2. Okay, so yung first equation sa case 2 ang gagamitin natin. So substituting equations, substituting values in the equation. Again, the resistance factor for web crippling is 0.75. Ayan, 0.75. Tapos yung Rn natin is using the formula 0.4. Thickness of the web square, then 1 plus 3 LB over D, this is D, times thickness of the web divided by thickness of the flange, okay, raised to 1.5, then everything multiplied by the square root of the elasticity, 200,000. Fy, take note, yung Fy na ginagamit natin dito is yung Fy ng beam. Kasi we are considering web crippling. And web crippling, yung web dito is part of the beam. Kaya Fy to ng beam, 345. Times thickness of the flange, 18. Divided by thickness of the web, 11. Tapos equate mo siya sa RU. Yung RU, yung calculated ultimate load natin. So from this quite long equation, we could solve for L sub B. So ang L sub B natin na nakuha ay 71.56. After having that L sub B, we verify our assumption if it is really less than 0.2. Yung LB over D natin, chinek natin. Unfortunately, na greater than 0.2 siya. So therefore, we made the wrong assumption. So therefore, we have to change the formula used for R sub n. But instead, we have to use the second formula for R sub n. No, yung pangalawa, yung huling equation natin. So using the last formula for LB over D greater than 0.2, so ito yung equation natin, we got another value for L sub B. Okay? And that is 71.48. Although konti lang yung difference ng value ng LB natin, no, kanina 0.56, ngayon 0.48. Konti lang yung difference. Pero of course, this is theoretical, so we have to follow this one. So then we validate again our ratio LB over D, and nagkataon naman na okay naman na siya. So ibig sabihin, it satisfies the condition. Therefore, for web crippling, the minimum length of the bearing plate would be 71.48, and if we round it up, let's say to multiples of 5 millimeters, so we will be arriving at 75 millimeters to be the minimum length of the bearing plate. Kanina, sa web yielding, ilan yung sagot natin sa web yielding? It's 50 millimeters, diba? Tapos sa web crippling, the answer is 75. So of course, to avoid web failure in general, we have to use yung 75 millimeters. So tapos na tayo sa length. So next step is for the width, B. And that could be designed based from bearing on the concrete support. So this is very much similar on the design of the column-based plate. Okay? So if you look at this figure, the given thickness of the wall is 200 mm. Yun da yung thickness ng concrete wall, 200 mm. Tapos yung na-solve nating LB kanina is 75. So ibig sabihin, pasok. No? Pasok yung length ng bearing plate natin. Kunwari, ito yung bearing plate, yung nasa pagitan nilang dalawa. So yung length ng bearing plate natin, 75 mm, pasok siya, less than siya dun sa width ng wall, yung thickness ng wall na 200. So ibig sabihin, kung i-analyze natin yung bearing, yung concrete support natin dito, the bearing plate is now resting on less than full area of the concrete wall. Less than full area. Kasi 200, mas malaki kaysa sa 75 eh. So less than full area. So di bali yung ayan, 75 is less than the thickness of the wall of 200. Therefore, the bearing plate would be on less than full area. So ano yung formula natin for Rn? Yung Rn, yun yung P sub P. 0.85 FC prime A1, may correction factor tayo ng square root of A2 over A1. Thus, you need to verify and check if it is less than 1.7 FC prime A1 later on. Okay. So, kung titingnan mo yung pinaka-plan view, ito yung top view. Okay, so yung kulay puti, yan yung bearing plate natin. So, ang length niya is 75. Tapos yung width niya is B. Yan yung hinahanap natin. So, length 75, tapos yung width niya is hinahanap. So, kailangan natin ma-solve yung A sub 2. A sub 2 would be the biggest rectangle similar dun sa bearing plate that we could have inside the pedestal. So since the thickness of the wall is 200, di ba ito yung 200 niya, no? Ito yung pinaka-concrete wall natin. So we will be considering or solving for the corresponding Z dimension para maging proportional, similar yung area ng bearing plate with the A sub 2. So yung A sub 1 natin would be the area of the bearing plate, and that would be 75 times B. Diba? Tapos yung area naman natin ng area 2 would be yung area ng kulay blue na rectangle, and that would be 200 times Z. Okay, so yan yung A1, 75 times B. Tapos yung A2 is 200 times Z. So by ratio and proportion, we could say that Z is to 200 as to B is to 75. So therefore, we could arrive with this relationship. Z is just equal to 8 over 3 of the B. Okay? So, substituting values in the equation for less than full area, so the R sub n would be 0.85. Okay? FC prime is 20.7. Tapos yung A1 natin, 75B. Tapos square root of yung A2 natin, yan yung Z. Yung A2 natin is 200 times Z. Ito yon. Tapos ito yung A1, 75B. Yan. Substitute mo lang lahat yan sa equation, maka-cancel lang yung B, no? Yung sa loob ng radical sign, maka-cancel lang yung B. Okay? So, tapos i-equate mo lang siya so yan yung lalabas na R sub n natin in terms of B, 3519B. Okay? So, yan yung Rn. So, applying it with the LRFD design principle, that the design strength should be greater than or equal to Ru. So 0.65 is the resistance factor for bearing. Tapos yung Rn natin, sinubstitute natin. Tapos yung Ru, yan yung sinolve natin na factored load. So we will solve for the B. Yan. So yan yung lumabas na width na kailangan natin. 223.84. Let's say round it up to the multiples of 25. So we will get 225. So yan na yung width, 225. Now, before we accept this with 225, we need to validate yung condition natin na eto. We have to check this one. Kung less than ba siya ng 1.7 FC prime A1. Ayan, so check the limit of Rn. So, yung Rn natin is back substituting the value of the B, which is 225. And check whether it is less than the 1.7 of FC prime A1. Ang lumabas, hindi siya nag-comply. No, 791,000 is greater than the 593,000. So, hindi siya nag-comply dun sa limit, therefore, nag-fail siya. Anong ibig sabihin nun? Papalitan natin ngayon yung formula na ginamit natin for Rn. But instead, we will replace the value of Rn to be the limit, which is 1.7 FC prime A1. So, yun na lang yung gagamitin natin. Then, we have to resolve for another value of the B. Okay, so paano gagawin yon? So, again, LRFD conditions. So, okay. So mas madali na yung equation natin, no? Kapag ka limit, Rn limit na yung gagamitin mo to be your Rn. So, 0.65, that's the resistance factor. Tapos ito yung limit, 1.7 FC prime A1 lang. A1 mo, 75B. Tapos equate it with the R sub U. So from there, we could easily solve for the B, 298. And round it up to multiples of 25, say we have 300 na. So ito na yung pinaka-final width na kailangan natin, 300 millimeters. So again, ano yung length natin kanina? 75, 'di ba? 75 yung length natin kanina, tapos yung width naman natin ngayon 300. Okay, so the last part of design would be thickness. Okay. For the minimum thickness required of this bearing plate, so again from previous calculation, we have identified yung N, ito yung LB, 75. Tapos yung width, 300. Okay? Tapos yung RU, 512,000 newtons. Tapos this time, since ang i-investigate natin dito is yung bending, so this should be bending. Bending of the plate. So plate property ang kailangan natin. Kaya yung Fy na gagamitin natin this time is on the Fy of the base plate, which is 248. Okay, so yung K property ng section was given. Tapos ito yung length N na mag-undergo ng bending. And again, yung width natin is 300. So we will have to solve for the thickness. Again, using the formula that we have modified. So the thickness would be that one. Should be greater than or equal to 2.22 RU. Ito yung RU. Okay, so we have the RU. Tapos yung N, diba from this figure, N is just equal to B minus 2K over 2. So yan yung N. We have the B, na-solve natin kanina, minus 2K over 2, tas square, naka-square siya eh. Divided by BLBFY. So B is 300, LB is the length, 75. And again, yung Fy na gagamitin dito is the Fy ng beam bearing plate, which is 248. So yun na. So direct substitution, solving for the thickness, lumabas 51.9. So rounded up to next say multiples of 5, we got 55. So that's it. So finally, so the design of our bearing plate would be A36. We have LB 75 by width 300 by thickness of 55. And that would be the actual final design of our bearing plate. Now, so that is how we design beam bearing plates based on the three possible limit states or mode of failures. Okay, so thank you for listening.